Hey, good morning, everybody. This is Mr. Aynesworth here, and we are going to be in part 3 here. We're going to go over proofs and using the Pythagorean identities that we developed in parts 1 and 2 in the section 7.5 here in AP Pre-Calc. Okay, so this is an optional section here. I just thought I'd throw it in because it's an application of what we're doing. Okay, so let's get started. All right, so we're going to take the left side here of the identity and prove that it's actually equal to the right side. So what we do in a proof is you start off with, again, the left side, cotangent theta minus tangent theta here, divided by sine theta times or it's actually cosine theta. That's a typo right there, so the t shouldn't be in there. All right, so that's just cosine theta there. All right, and we're going to show through a series of steps that's actually equal to cosecant squared theta minus secant squared theta, using a bunch of algebra, believe it or not, basic algebra, and a few identities. All right, so here's what we're going to do. One of the things that I taught you in part 2, so let's go back to part 2. Actually, I did it in part 1 as well. Back in example 1 is I rewrite all functions in terms of sine and cosine. I did that multiple times, okay? And what we're going to do is we're going to start off with that. So the basic technique we learned earlier, we're going to try now. Okay, so here we go. So cotangent theta is cosine theta divided by sine theta. And make sure you put in the theta because theta is your angle. I see a lot of students leave out the angle and it doesn't mean anything without theta. Okay, so remember cotangent is a function and theta is your input in your angle, and you absolutely need that. Okay, now minus tangent theta, which is sine theta divided by cosine theta. All right, this is all divided by sine theta times cosine theta. All right, now typically you don't want a difference of fractions within a fraction. Okay, so you want to combine fractions here. So we need to do that. And this is where your arithmetic comes in. Okay, you guys got to be good at fractions. And if you were with me in class, I teach a quick method called the 3-product rule, where when I add or subtract fractions, and I don't care how complicated they look, I do this in calculus all the time. I just multiply here, and then multiply here on the diagonal, and then I multiply a third time on the denominators, and I combine my fractions. So I do it through multiplication. Okay, so here we go. Now in the numerator, I take cosine theta times cosine theta, which is obviously cosine squared theta, minus, because there's a minus sign right in the middle, right? You're subtracting. Sine theta times sine theta is sine squared theta, and then you got to multiply the denominators, and that's sine theta times cosine theta, all right? And this is all divided by the denominator, which is obviously sine theta times cosine theta. So what in the world does this equal? Well, instead of writing as a fraction divided by something, let's take the numerator, which is this fraction up top. Okay, let's start off with that. So cosine squared theta minus sine squared theta, all divided by sine theta times cosine theta, and let's multiply by the reciprocal. Okay, and the reciprocal of sine theta times cosine theta is 1 over that. So I'm just kind of rewriting it in a different way. And the reason why is because usually dealing with multiplication of fractions is a whole lot easier for people than division, okay? Well, when you multiply fractions, you just multiply up top, multiply down below. So up top, well, we just have cosine squared theta minus sine squared theta times 1, which is just itself. And then down below, I'm talking about here, when you multiply these denominators, sine times sine is sine squared. So you get sine squared theta down here, and cosine theta times cosine theta is cosine squared theta, and you're multiplying these. So how is this equal to this end result? Well, we're going to split the fraction. All right, there's a minus sign right here. So I'm going to divide here, and I'm going to divide here. And I'm going to split the fraction. Now, if you don't understand what I'm doing here, I'm doing something like this in grade school. So if I have 2 minus 3 divided by 5, I can take 2 divided by 5 minus 3 divided by 5. Okay, I can split the fraction. All right, that's what I'm doing. So here we go. So watch this. Cosine squared theta divided by your denominator, sine squared theta times cosine squared theta, minus, because there's a minus sign, right? Sine squared theta divided by the denominator, the same denominator, sine squared theta times cosine squared theta. And then all you have to do is simplify. Now watch this. Okay, anything divided by itself is 1. So this first fraction gives you cosecant squared theta because 1 over sine squared theta is the reciprocal function cosecant squared theta. And then here, this is 1 divided by cosine squared theta, which is secant squared theta, because these are the reciprocal functions. By definition, that's what they're equal. And then voila, we show that the left side equals the right side through a series of algebraic steps. All right, and this is something that if you practice a little bit, you can get good at. All right, let's try it again. Let's take a look at this next one here. Okay, so we got to prove that this complicated expression here, so cotangent of A, all right, it doesn't matter what variable you use, so they're using A here, so who cares? You just got to go with the flow, times 1 plus tangent squared A, where A is your angle, divided by the tangent of A. Well, guess what? That's equal to the simple expression cosecant squared A. Holy cow. Okay, so how are we going to do that? Well, you do it like we have always done. So this one may be easier than we think. Okay, so let's go back in time here. Let's do the flux capacitor. Go back to the initial lesson here, and let's take a look at the original identities. And look at this. 1 plus tangent squared theta equals secant squared theta. It's equation number 2. I'm going to write that down. This is why knowing your identities really helps. So I'm going to say we knew, okay, 1 plus tangent squared theta, all right, is equal to secant squared theta. So I don't care whether you have theta or A, it's the same identity. All right, so this right here, this expression here, 1 plus tangent squared theta, that's nothing more than secant squared theta. So I'm going to say this is equal to cotangent theta, all right, times secant squared, not theta, but A, I'm sorry, and then divided by tangent of A. So here, this is where I suggest we rewrite in terms of sine and cosine. So we should probably do that. Yeah, we should probably do that. So rewrite in terms of sine and cosine, which is what I suggested to do in the very beginning of the lesson in part 1. Okay, just so that you can see things. Now, cotangent A is the same thing as cosine of A divided by sine of A. Okay, secant squared A is just 1 over cosine squared A. And the denominator, that's sine of A divided by cosine of A. So how in the world does this all work out? Well, let's take the top up here. And actually, we can simplify the top, can't we? Sure we can. Okay, so this cosine A here cancels out with one of these, leaving just cosine A here. So in the numerator here, I have 1 divided by sine of A times cosine of A. And then I'm going to multiply by the reciprocal, so save some time. Cosine of A divided by sine of A. So right there, I multiplied by the reciprocal. So again, a lot of grade school math. Multiply by the reciprocal. We've been talking about reciprocals a lot lately. Okay, so from here to here, right? I multiply by the reciprocal. So instead of dividing by sine A over cosine A, I multiply by cosine A over sine A, which is called the reciprocal. Well, watch what happens. Okay, this cosine A cancels out with this one here. And guess what? Sine A times sine A in the bottom here becomes 1 over sine squared a, because when you multiply these functions, sine a times sine a gives you sine squared a, right? And then 1 times cosine a, well, the cosine a is canceled out. And then, guess what? This is the definition of the reciprocal function. So again, this lesson here in 7.5 is all about reciprocal functions. And that's why I put these in here, because they are really useful. And they help you determine, or not determine,